Hello guys, my name is Sandip and today we are going to learn some very important concept, right? In previous session, we have already completed the chapter which is called as force. That is our very first chapter, right? Very interesting, right? And I also told you to search on that why sheep is floating on the water, very big sheep. Right? Hopefully you must have searched on that now and you should have the concept clear why it is floating on that water, we can say. Okay. So today we are going to start a new chapter, brand new chapter, which is called as friction. Right? So we have already studied about the friction in the even in the first chapter only. Right? Can anybody tell me whether this friction is a contact force or non-contact force? That's right. That is a contact force, right? Okay. So now we are going to study in detail what is this static friction, kinetic friction, and etc. etc. So let's start. So here, now first of all, we have seen this image or in videos like this in movies lot of times, right? What is happening, right? The person is sleeping on that banana peel, right? Why is that? Right? Before on the floor is very easily walking, right? But when there is a banana peel, what is happening there? That's why he's sleeping like that. Right? Is it something related to friction? Obviously, if this is our chapter, we are going to say obviously yes, that's related to friction. Right? Okay. So tell me what is happening in this case when there is a banana peel. The friction we are talking about is reducing or increasing. Obviously, it is reducing, right? It is becoming smooth. Simple thing, right? Okay. Now let's take one more example. Now, consider your mom told you to go to the shop which is nearby and buy something, right? Buy some chocolates or etc. etc. Then you have two options. Either you can start walking towards the shop, or another thing, you have the skating shoes or skateboard, right? Which one you will prefer? Obviously skating shoes, right? Why? Because it is very easy to roll on that, right? Again, I will use the word, it is very easy to roll on that. Roll means obviously that rolling skates or skate shoes, we can say skateboard, has the small, we can say small wheel, right? It is just similar to our tire of our bike or car. It is also rolling, right? Okay. So can I say rolling is easier than walking? Obviously. Why? Because rolling is going to decrease your friction, right? Okay. And walking is going to be difficult, obviously. So can I say another thing that anything which is rolling, and now consider one block, instead of your walking, now consider one block. If I started pushing that and consider one tire or anything spherical or ball, we can say it is rolling. Which one is easier? Which will be easier? Obviously rolling one, right? Okay. So this is all related to friction, we can say. Now let's watch a very small video, so we'll get a general idea on what is friction. Okay.
There are at least 4 types of friction: static, sliding, rolling, and fluid friction. Static, sliding, and rolling friction occur between solid surfaces, and fluid friction occurs in liquids and gases. Static friction occurs when an object is resting on a surface. The static friction between these boots and the snow allows this person to stand and shovel snow. When you rub your hands together, you experience sliding friction. When you ride a bike, you depend on the rolling friction of the tires. And skydiving depends on the fluid friction between the air and hopefully the parachute opening to slow the person down. Friction is used in everyday life. Sometimes you want a great deal of friction, like the gripping power of tires, and other times, like when you go skating, you want low friction so that you can glide across the ice. Most land vehicles rely on friction for acceleration and changing direction. And fluid friction contributes to aerodynamic drag, which is the resistance to forward motion. so that race cars are sleek and aerodynamic to reduce this fluid friction and go faster. Your shoes provide friction which allows you to move forward. Also, if the friction is really low, like on ice, it's challenging to drive a car because of the low friction. Skis on snow work the same ways, and the low friction allows the ski to glide quickly over the ice or snow. Sandpaper, on the other hand, works because its surface increases the amount of friction. Wax is applied to surfboards to increase friction and grip, and you put oil on chains and gears to decrease friction, and this allows the chain to work more efficiently. And finally, the wheels on this skateboard create a great deal of friction and allows these people to go up and down skateboard ramps. If you'd like to know more about friction,
Okay, so this is the different types of friction. There is one more friction we are supposed to study, that is the fluid friction, right? We'll study more about that in the next session actually. So today we are going to talk about the mechanics part of the friction. There is so there are three types of friction, right? Static, kinetic, and rolling. We already know that rolling friction is less than our static friction, right? So tell me one thing, this friction, as we said, if for walking or sliding the block, friction is more than rolling. Right? So tell me, friction should be less or more? Less, that's good. Now tell me, the friction should be zero or non-zero. So is it okay if the friction, there is no friction between the surface? Right? And I say if the friction is, there is no friction, obviously I will go very quickly to the shop and bring whatever I want, right? It is very easier than even than rolling, we can say, right? There will be no friction at all, right? But yes, we can say that friction is also necessary thing, because we cannot walk on the ground also, that if there is no friction, we have seen that in our video right now, right? For walking also, when we are walking, what is happening in that case, right? We are actually pushing the ground behind, and the frictional force is pushing us forward, right? That is the actual mechanism of walking, we can say. So friction, obviously, we need the friction, but it should not be a lot more than that. Even in this case, their friction was very less, therefore this man is sleeping, right? Simple. Now, now let's start our chapter friction, and let's see what we have to cover in this friction. So, introduction to friction. Right now, we already have talked about the friction. We also have seen the friction in the previous chapter. That is force. We also know that it is a contact force. If you do remember, I also told you that it is a self-adjusting force. We will again see that what is the meaning of self-adjusting, right? Then, second point is factors affecting friction, right? So who is causing the friction, or you can say what is the cause of friction, we will also see that one. Then types of friction, as we can see, there are three different types, that is static, kinetic, and rolling friction. We already know this thing. Rolling means there should be wheel, obviously, right? And we also know that rolling friction is less than our kinetic friction. We will also study what is the static friction. Then the limiting static friction, obviously as the name suggests, can I say limiting static friction is a type of static friction? Yes, that's right. And we also saw in the video about a fluid friction. Fluid friction means what? Fluid means what? Is it just the liquid? No. It is liquid as well as gases, we can say, right? So we can say fluid is also, air is also fluid, right? You must have heard that meteor shower, right? What happens in that case? The big rocks, we can say, they are coming from the space towards our ground due to our Earth's gravitational field, right? But when they are coming, actually, the air resistance or friction due to air is very high, and instead of that, I can even say that the velocity of that rock is very high, right? Therefore, friction generated is very high in that case. Therefore, it gets converted into heat and it looks like a light, right? We do say that meteor shower is very nice to look at, right? Obviously, it is nice, right? But it is due to this friction. That is the friction because of air resistance. So, even if you can consider air resistance is also a very valuable, or we can say big force, actually, right? normally we do neglect those force. Air resistance is nothing like that, right? Very small force. But you can see in that case, the meteor is coming at very high speed. Obviously, there could be a air resistance. Even in the video we just watched, in the racing cars also air resistance do play some part there. It opposes the motion of the racing car, right? So that's why they give the shape to the car like that. That is called as aerodynamic shape, which will be easier or to minimize the air resistance, we can say, right? So these are the different things about the friction. Now let's talk. So what is the friction? So first of all, we already know that the friction is what? Force resisting the motion of any body, we can say. So when we are walking, friction is helping us in that case. Now consider this example is very easy to understand. If you are pushing something, right? Now consider a simple case. If you want to move your furniture around, right? So what you do actually, and you suppose you want to move the very big cupboard, right? Can you alone move that cupboard? No, you cannot. Why? Because obviously it is very heavy. Who is opposing the motion? That is the friction. So if the floor is smooth, then it will be easier. If the floor is rough, then it is going to be very difficult task, right? So even consider our freeze washing machine. Nowadays washing machine or freeze also have some wheels, right? Wheels, or we can say spherical balls there at their legs, right? Which makes them very easier to move, right? That is actually the rolling motion, we can say. Because of the rolling motion we can easily move that washing machine. But consider if it does not have the wheels, what will happen? You have to push that. Now again it will be a very difficult. So again, it is a part of the rolling motion or rolling friction or kinetic friction, etc. Right? So friction is what? Simple, we can say friction is the force which is resisting the relative motion of the body over the other, or simply we can say motion of the opposes the motion, right? Okay. Now let's see what is the cause of this motion. Right? So cause of friction, not motion. So why we are getting the friction there? Now consider when we see any object, right? Let's say even our floor, right? If you consider that floor, it is very smooth, right? Now go and watch very closely to it, right? Or use a magnifier to look at it, zoom it, right? If you zoom it, then it is not very smooth. It will look something like this. It is a rough patch, something like this, right? Now consider if you want to move any object on that. Even the object plane, you can see it is a very smooth plane. But again, if you magnify that plane, you will see something like this. So consider this is the plane. It will be like this. Right? So there are irregularities in this two contact, we can say. So what is happening? This hill part is going to get into this part which is at depth, we can say, right? So heel part of the one object is going to get into the depth of the other part and it get locked. This is called as interlocking, right? This is called as interlocking, and this interlocking is going to provide you some friction, some opposition to move that object on that rough patch, we can say, right? So this is very easy to understand. Therefore we say that there is a friction. So we can say this is the cause of friction. Okay. Then, right? So it doesn't matter whether you are pushing or pulling the object, there must be a friction. Now let's see what are the factors. What are the factors affecting this friction? Okay. So tell me one thing. Is it easier to move? Consider a big cupboard or let's say your table. Which one is easier to move? Obviously, table is very easier to move. Why it is easier to move? Because we can say that friction is also dependent on the mass of the object. Very simple. If it is heavy object, it is going to be very there. We will need at least 2-3 guys to push that or pull that object, right? So obviously, it is dependent on mass. You can say. Then can I say it is dependent on the nature of the surfaces in contact. means whether it is rough or smooth. Again, I said earlier also, if the surface is very smooth, then it is very easy to pull or push the object, right? Then also we can say it is independent of the surface of contact. So let's do one thing. There are some laws of friction. We will point those out. That will be easier to understand. Laws of friction. Let's say first law is it acts tangential and tangential to plane, we can say tangential to plane, and opposite to applied force. This is a very important law, we can say, or property of the friction. This we can also say this is the self-adjusting thing. Self-adjusting. What is the meaning of self-adjusting? I already discussed this in the forces chapter also. Now consider if the block is kept here, what happens if I apply some force here? The friction force also gets applied onto the opposite side, right? So this is the frictional force, we can say. Self-adjusting. Why I'm saying it is self-adjusting? Now consider in second case, if you apply the force on this direction, frictional force will get at on the opposite direction. So this is why we are saying that friction force is self-adjusting. It is adjusting its own direction, not only direction, but it also adjusts its own its magnitude also. It depends on if I apply the force 10 Newton, this friction force also becomes 10 Newton, right? Assuming this mass is very, very heavy. There are some laws, we will see that one too, right? So if you apply, obviously, if you apply the very big mass, this friction force is not going to be similar to that one, right? And we'll see that one, right? But currently we can say it is a self-adjusting force. If you remove this force, friction will also get removed. So the frictional force will be zero. If applied force is zero, frictional force will also be zero. So that's why I'm saying that it is a self-adjusting force. Then second point I can write, it depends on nature of the material, nature of two surfaces. Right? So what is the meaning of that? It depends on nature of the surfaces means whether the surfaces are smooth or rough. Obviously, it depends on that, right? It's very easy to understand. Then it is independent of area in contact. Area in contact. Now let's see what is the meaning of that. Consider two cases. If this is our table, and the second case, consider there are two blocks of 5 kg, 5 kg. I kept it like this, right? Which are, let's say, connected to each other. And if we apply the force, they both will start moving in the same direction, right? Together, you can say. So this is one case. And in second case, I'm putting this object like this. Here, consider this is the area. Let me call this as A. Right? Tell me what will be the area in contact here. If this is A, I think this could be the A by 2 area, right? So if the area decreases, area in contact decreases, doesn't matter. Friction force is independent of that, right? So it doesn't see what is the area in contact. It just see how many mass is there, right? And what is the frictional coefficient, we can say. We are going to study that next also, right? So just remember here, it is independent of the area in contact, we can say. Then fourth point, it is proportional to weight of the body. Weight means we know, right? Weight is nothing but mass into acceleration, or we can say mass into g, right? That is weight of the body, which tends to move, or simply you can remember that proportional to the weight of the body. It tends to move, you can say. And one more law I can say is it is proportional to It is proportional to normal force, I can say, or normal provided by the surface. Now we already talked about not this normal. We know what is the normal force, right? If this is the object, we know the normal acts upward like this, right? So what we can say, this frictional force is directly proportional to this normal, or I can substitute. This is the directly proportional sign, right? Just remove this directly proportional sign, put the equal to sign there, and add one constant. That constant we are going to call it as mu. Mu is called as, this mu is coefficient of friction. So it depends whether it is a static friction, rolling friction, or kinetic friction, right? Okay, so these are the different laws of the friction that will give us the idea how this friction works. Okay, sure. So now, as we were saying, there are three types of the friction. One is static, then second is kinetic. Which one is the third? That's rolling. That's good, right? So static, kinetic, rolling. Now let's talk about the static friction first. Static means, what is the meaning of the static? What is the word static? You are going to encounter this word a lot of times. That is statics, electrostatics, you can say, or I can say fluid static, you can say, right? And static friction is there. So what is the meaning of this word? Normal meaning of it, right? Static means, remember, static means the object which is at rest. Simple. Okay, so as we know now, we now know the meaning of static. Obviously there will be easier to understand what is the static friction, right? Now let's see. So here I can see static friction is defined as what? Frictional force that acts between the surfaces when they are at rest with respect to each other. Okay. So what is happening in this case? You can see here, this person is trying to move that block, but that block is not getting moved. Right. So it is at rest. Can I say it is at rest? Yes, obviously. So if it is at rest and there is a friction there in between that block, and we can see this ground, then that friction we are going to call it as static friction. Okay. So let's see. So let's take this example. I will redraw this diagram, or consider our block is kept on this table. And now let's see if we are applying some force here. As we already know that frictional force is what? Self-adjusting force. So it is going to act in which direction? Right or left? That's right. Left direction, right? So let me show the frictional force will act like this. Now let me call this as EFS. EFS means static force of friction, we can say. Okay. Now, as we said, this object is at rest. So can I say the velocity is equal to 0? Right? If the velocity is equal to 0, can I say it is in equilibrium? That's right too. If it is in equilibrium, what is the condition? All the forces which are acting on that object should be cancelled out. Now let's try to draw FBD, right? FBD means free body diagram. Tell me how many other, these two forces, this is the external force, this is the frictional force. What are the other forces acting on that object? Yes, mg. Mg is the force which acts every time as long as there is a gravity, right? And this is normal. So can I say if it is in equilibrium, vertically equal forces will equate to the, we can say horizontally equal forces. So let's talk about the vertical first. So vertically I can say N is equal to what? Mg, right? What about horizontal? Can I say F is equal to Fs? Okay. So this is the formula. So as long as there is a, or we can say object is at rest, there is a friction force which is acting opposite to the external force, and its magnitude is also equal to external force, right? This is very simple. It is in equilibrium, and therefore we can say external force is equal to Fs. Now we have already learned one formula here. that frictional force is mu n. It is directly proportional to what? N. So let's write that formula. So can I say F is equal to Fs is equal to, let's say, mu s into n. Here again mu s is what? Coefficient of, here you can see I have written coefficient of friction. Now this is a static friction. So let's write this as coefficient of static friction. Simple. Okay. So this is called as Fs. Now can I say using this vertical condition that this is nothing but mu s into mg? Right. Now, though this is the static friction, instead of static friction, I can also say this is the limiting friction, or it will be even better or correct. I can say if instead of static friction, I represented it by FL for this formula I'm talking about. Right? So why I'm saying it is a limiting force of friction? At the start we said that limiting static friction is the we can say type of static friction, right? Now let's learn what is the difference between that limiting and static force of friction. I have already given you the idea in the chapter in the fourth chapter, but let's see what is this static and limiting force of friction. Right now, consider if this block is there of let's say 5 kg, right? So what I can say 5 into g, or let's say g is equal to approximately 10, right? Approximately we can take it as 10 meter per second. So can I say this is 15 Newton force is acting downward, that is weight, normal is acting upward, right? So let's use this formula first, which I have called it as FL. FL means limiting force of friction. It is mu into n, right? Now what is mu? Let's get value of mu as, let's say, 0.4, right? What I'm saying, value of mu is a 0.4. Remember, this does not have any unit. This is unitless. Mu does not have any unit. Okay. Then this is the formula. N is how much? If you equate this again, can I say n is equal to 50? That's good. So let's substitute it here. So this mu becomes 0.4 into 50. That's good. So this is 20 Newton. So I got the force as 20 Newton. Now let's see what is this limiting force of friction and what is static force of friction, right? So as we know that we are going to apply some force, so I will do one thing. I'm going to draw applied force, one table, applied force, and let's say frictional force. Frictional force. Now consider if I apply the force of 5 Newton, or let's say at the start there is no force. Can I say frictional force is 0, right? We have already seen this concept. If I apply the force of 5 Newton, what will happen? Again, the force in the opposite direction, in this direction, right, will become 5 Newton. We know it is a self-adjusting force. It adjusts the magnitude as well as direction. What happens if I apply the 10 Newton? Similar 10 Newton. For 15, again 15, that's right. What happens when I apply the 20 Newton force? Now we have said that this is the limit of limiting force of friction, means even every friction has some value, every frictional force has some limit up to which it is going to oppose, right? Because anyway, if you want to move the cupboard, you are going to apply some force. If it is not enough, you are going to call your friends and you 2 3 guys are going to push that cupboard, but you will be successful, obviously. Why? Because obviously there is some limit, and this is the limit, which depends on what? It depends on our normal, or I can say it is dependent on mass, right? So if you apply the 20 Newton force, if the required force, that is the limiting friction, is also 20 Newton, now what I can say here, you are applying the force which is required, right? 20 Newton. So at the 20 Newton, it is just going to start, or we can say it tends to move we can say, right? So this is the formula, we can say this is called as limiting force. Okay, then now let's move forward. Now this is the condition we have seen that here up to this condition up to 20 Newton, what is going to happen? There is a static force of friction and the maximum value of friction is called as limiting force of friction. Okay. Now let's do one thing. Let's try to draw one graph against the applied force, and let's say this is our frictional force, right? So applied force on the x-axis and the frictional force on the y-axis, right? I will mark here some points. If the applied force is start with 0, then 5, then 10, 15, let's say 20, and this is 25. Similarly, I can say 5, 10, then let's be right? So let's say this is 5, 10, then we have 15 on here, 20, and 25. Let's try to draw this graph, plot this graph. We already got the table. When the force is 0, we can say this is 0, 0 is our point, right? So this is how we plot the graph. For 5, 5, what we do? With the 5, 5 lines, intersection point will give us some point. Similarly, 10, 10, 15, 15, and 20, 20, right? Okay. So we got the graph which will give you a straight line like this. So can I say this frictional force is, or I can say frictional force is directly proportional to applied force, right? That's good. Okay. Tell me what will happen if we increase this force, right? Now, when I said you are moving your cupboard, and when you started, when you apply the sufficient force, which is equal to limiting force of friction, that is the maximum limit of our friction, then what is going to happen? That cupboard is slightly starting to move. Very simple. Good. Now, what happens if you apply the more force? Obviously, if you want to push it, you are going to apply more force. Let's say now you are applying the 25 Newton. What will be the, sorry, here it is 25 Newton, right? Yes. So what will be the frictional force in this case? Is it 20 Newton or 25 Newton, or where there will be or there will be no friction, right? So for that part, we have to study the second type of friction, which is called as kinetic friction, right? So this is our second type of friction, kinetic friction, and which is defined as the resistance, right? Again, we know friction is anyway resistance, it is the opposition. So again, I can say kinetic friction is what? Kinetic friction is the resistance that is created between any two objects when they are sliding against each other. So let's see what is the meaning of that. Using the same diagram, this is our person, right, who was trying to push this object, or you can consider our own example that we were trying to what? Push the cupboard. We were unable to do that. So what we are going to do now? We are going to all our friends like this, and now they are also going to help us pushing this, right? So force increases. So force increases means we have already seen if the force increases, if it becomes equal to the our limiting force of friction. Limiting force of friction means what? It is the opposition, maximum opposition offered by what? That frictional force, right? Now we got the force, enough force, so applied force is equal to, or I can say let's say greater than, right? Greater than the frictional force. What will happen? This block, that cupboard is going to start moving, right? So when we say the cupboard is now start to move, or this block is start to move, means they are sliding against each other, right? So again there is a friction which is called as kinetic friction, right? So now in the previous case, when the object was at rest, there was a static force of friction. Now here we can say when the object started moving, it is sliding now, then we can say it is kinetic force of friction. Okay. So let's try to write the formula for the same. So I will draw the similar diagram which we have drawn earlier. So this is our block. right, of 5 kg, right? 5 kg was the block. Again, we have the normal force upward, and who is downward? That's right, EMG is downward. Let's say applied force is here, and where is the frictional force? On the opposite side, as we know, it is a self-adjusting force. Instead of FR, let's call this as FK. Why FK? Here is the kinetic force of friction now, right? Very simple thing. Okay, we got all the forces marked here. Now, in the previous case, you can see here I have written V is equal to 0. Why? Because it is at rest. Now this is that was at equilibrium. Now in this case, V is not equal to 0. Even I can say acceleration is not equal to 0. Right? Where it is going to move? If the external force is greater, it will move in along this direction. Okay, so this is the condition. Acceleration is in that way. Obviously, the external force is now what? It is overcoming our frictional force. If it is overcoming frictional force, it is going to move. Let's say with acceleration A. Now let's find out the formula. Now formula is same. FL is equal to, not FL, FK, right? F is equal to mu n, right? So instead of mu, only mu, let's write it as mu k. Here we have written it is a coefficient of static friction. Now this is, I can call this as a coefficient of kinetic friction. Again, it will not have any unit, right? You can see this formula is just similar. There is no difference in that, right? So if n is equal to mg in this case, if I equate the vertical force, right? Remember one more point here. Even though I am saying that this is not in equilibrium, still we are going to equate the vertical force. Why we are going to equate vertical force? Because that block is only moving in the horizontal direction, not in vertical direction. So I can even say this is in vertically equilibrium. This is the vertical equilibrium. Means it is not going up or it is not coming down, right? So let's call this as vertical equilibrium. So if it is in vertical equilibrium, I can again say equate the vertical forces, that is n is equal to mg, right? Very simple thing. So again, I can repeat here, that is mu k into mg. K is subscript here. Yes. So again, we can say this frictional force is dependent on what? Mass, then acceleration due to gravity, then our coefficient of friction and all those things. Okay. Now, one more thing. As we have already said at the start, that rolling is easier than what? Sliding or walking, we can say. So tell me, is it easy to roll the sphere or push this block? Right? Obviously, rolling will be easier than pushing the block. Okay. Now tell me, is it easy to start the motion of this block? Consider our own example, that is we were moving the cupboard, right? Right? Tell me, when you're pushing that cupboard, right? You applied some force, right? You called your 2 3 friends and applied the more force, etc. Once it starts moving, do you think it needs the same amount of force if it is in motion? No, it requires a less force, right? It is same thing as the rolling, right? Rolling requires this minimum force or less force than kinetic. Similarly, I can say kinetic force or force against the kinetic friction will be less. It required force will be less compared to what? Static force of friction, right? Means it is easier to slide the object than to start the motion of the object, we can say, right? So remember here I can say frictional force or kinetic force is less than static force of friction. Remember this part. Or it depends on mu k. So I can say mu k is less than this mu s. Okay, so these are the important concepts we should know. Okay, now Let's consider our this example. In this example, we have said 5 kg block is there. G is 10 meter per second square, approximately, obviously, right? Mu s, we can say mu s was 0.4. And now let's use the same values. Only this mu k is going to change, right? What is the value of mu k? Let's take the arbitrary value, that is 0.3, right? Our mu s is how much? Mu s was uh, 0.4, right? So mu k, I can say it is 0.3 now. Okay, it obviously it should be less than our mu s. Okay, and now let's try to calculate this. So we were here that mu k, that is frictional kinetic force of friction, was how much? 15 Newton. Now let's consider this same example. What we were saying, that initially applied force was, we increased the force, frictional force, that is the static force of friction. It also increases, that is the self-adjusting force. We know that, right? So can I say up to this point, this is the static force of friction. Even you can 16, 17, 18, up to 20. 20 is our limiting force of friction. Limiting force of friction. Okay, so just a minute. Let me change the sides. This is actually the applied force. Now let's write it here. So this is our static force of friction. And this one is our limiting force of friction, right? Now after that, now body has started moving, right? And we already know that the kinetic force of friction is less than that of static force of friction. So maximum limit of static force of friction was 20. What is the force of friction? 15 Newton. Now, what is the meaning of that? This object is going to oppose by only 15 Newton of force, right? It cannot oppose by 20. So when it was at rest, it was opposing up to 20 Newton. So it doesn't matter if you apply the 18 Newton, 19 Newton, it is not going to move, right? But what is happening now? Its force of friction becomes less. So now remember, instead of even 20, if you just increase it, let's say 21 Newton, this force of friction is neither 21 nor 20, but it is going to be 15 Newton only, right? So again, 22, 25, you can take any value, it is going to be 15 Newton only, 30 Newton, right? It is 15 Newton. It is not going to change now. Okay, so simple thing. What we see, what we learn here, static force of friction is going to, it has the maximum limiting value, after which that frictional force is going to decrease, right? And this force is now we are going to call it as kinetic force of friction. Okay, now let's try to plot this in graph. This is our graph now, right? What happened? If we apply the 20, just consider if you apply the just little bit more force than this 20 Newton, what is going to happen? If we apply the little bit force more than 20, it is going to be a 15 Newton force now. Okay, if you apply the 25, it is going to be 15. It is not going to change. If you apply 30, same. If you increase the force, same. Right? Doesn't matter how much applied force is, it is going to remain same. This our graph will look now. This. So this is the graph of applied force versus frictional force. right? The green line shows you the static force of friction, we can say. The maximum point of that friction is the limiting force of friction, and the red line is going to show you the kinetic force of friction. Okay. So these are the difference between force of frictions, right? So now let's solve one question. I'll give you one question and try to solve that one. Okay. Consider the mass of the object is 10 kg, right? And I'm applying the force of 8 Newton here. Okay. Now the question says, what will be the frictional force? They have also given you the mu. Let's say mu is equal to, again, let's say 0.6. Mu is 0.6. 10 kg is given, and what will be the force? Okay. Again, you can consider G is equal to 10. Okay. So let's say first option is 60 Newton. Second option is 20 Newton. Then 4 Newton. D is your 8 Newton. Okay. So these are the options given. And you want to find out what is the frictional force here. So we already know the formula, right? Frictional force is what? Let's see. They have given us the two values of mu s. That is, let's say one is 0.6, and let's take another value, that is the mu k. So this is 0.5. Okay. Now we know the formula. Force is equal to, frictional force is equal to what? Mu into n. Now, which mu we are supposed to use? That is mu k or mu s. That is the important thing, right? So yes, anybody can guess which mu should we use here. Okay, so what we have to do, first of all, we don't know which mu we have to use, whether it is kinetic friction or static friction. We don't know anything about this one. So first of all, we are going to calculate the limiting force of friction. And for the limiting force of friction, we use the mu of static force of friction, that is mu s. So let's substitute here. Can I say mu s n is equal to mg, right? I know that mg and n are vertically opposite, so I can equate it here for this particular case. So mu s is equal to how much? That is given as 0.6. M is 10. Acceleration due to gravity is 10. So what will be my answer? 60 Newton. Right. So what I got, that is the maximum friction offered by the block, we can say. Right. So what will happen if I apply the 8 Newton force? Will the body move? No, body is not moving, obviously, right? Because the body can apply this much of friction, that is very high. So 8 Newton force applied, body will not move. So tell me, what will be this frictional force value? Right, so this frictional force will be how much? Is it 60? We got the 60 as answer. No, because this is the maximum force of friction. But friction force is a self-adjusting force. If we applied the less force than that, in this table, right? You plot the table that whatever force we applied, frictional force is getting equal to that until it reaches the maximum limiting force of value or greater than that, right? So here, what should be my answer? Force as it is applied force as it is a less than limiting value, then we can say frictional force is also equal to our this force, right? So my answer will be 8 Newton. Okay, so remember this type of questions could come into the exam, so we should be able to solve this. Okay, so these are the difference between the kinetic frictions and static friction. Now let's talk about the rolling friction. Third type is rolling friction. Right. So what we can say, rolling friction is what? It is a force which resists or oppose, we can say. Resist what? The motion of ball or wheel. We know rolling friction occurs when we have the skate shoes or the car is there, tire is rotating, right? Rolling means obviously it's object should be rolling, obviously. So it is a friction or force, we can say, which raises the motion of ball or wheel, or you can use the word here roller. Right? Roller means anything which can roll. Obviously, it could be a spherical or ring type shape or disc type shape. And okay, and they are saying it is the weakest type of friction, right? It is the weakest force. We already know that rolling force of friction requires a very less effort, right? So what we can say, Fr is a rolling force, right? Can I say it is less than Fk? Right? Can I say this is less than Fs? So which one is the strongest one? Static force of friction. We will require a lot of force to just start the motion of that moving that cupboard or any very high object, we can say. But kinetic friction will be less than that, and rolling friction is obviously very small than compared to our kinetic friction. Using this, can I say mu r is less than mu k is less than mu s, right? We already know mu s. What is mu s? Coefficient of static friction. What is mu k? Mu k is coefficient of kinetic friction. And tell me what will be the mu r in this case? Mu r will be coefficient of kinetic friction, right? Simple. Then, as we know that kinetic friction is very small. Again, formula will be same. Again, FL will be how much? FL, I can say mu n, and let's call this as rolling friction. Obviously, we cannot take the example of block. My block is not going to roll, no? Right? So, which object can roll? As we already said, we can call those as roller, right? It could be a spherical ball or a wheel or a ring, or even you can consider the cylinder. So those are the rolling objects, we can say, and it is going to be very easy. Now, let's take one example here. When you know that sheeps are in the ocean, but when we manufacture the sheep or prepare the sheep, that is a very big sheep, right? Consider this is the ocean here. This is the ocean, and what we have to do, we want to push this sheep, right? Sheep is very big, right? We want to push this sheep into the ocean. What we can do, obviously we can try to push that, right? First there will be a sliding motion, not sliding, static force of friction, we can say. Static force of friction means what? It is at rest, so whatever force you are going to apply, equal and opposite force will get applied here. Then what we can do, we can increase the force from this side. Obviously the persons cannot push it, we will need some machines for that, right? So we can increase the force of friction will again increase. If we reach, it will reach the maximum frictional force, that is limiting force of friction. After that it is going to start moving, right? Then slowly it will go up to the ocean. But anyway, this is going to require a lot of force because it is a very heavy ship. We already know that mass is very high, so frictional force is dependent on mass. So obviously frictional force will be very high. Okay? So what they do in this case, remember, they uh, put this ship on the objects which are cylindrical like this, cylinder type objects. The cylinder type objects can roll. So this below this boat, we can say, keep the object like this, which can actually roll. So what is going to happen? Now if you push, if you apply some force on this ship, instead of the kinetic friction, the cylinders are going to roll around the axis of themselves, right? Consider this is the cylinder. It will roll like this, right? In the circular fashion. This will start rolling, and obviously the ship is on that rolling cylinders. So ship will go ahead and ahead. right? But instead of using the kinetic force of friction, now we are using the rolling force of friction, which is now which becomes very easy to roll this ship into the water. Now that will go into the water like this. Okay, so this is the process normally they use to push the ship into the ocean or water, we can say. Why? Because the rolling friction is very, very small compared to your kinetic friction. Okay, so these are the different types of friction we have learned today. So let's take a small recap what we have learned. There are three, first of all, let's say cause of friction. Why? If you zoom any object, any surface, it is not a smooth, it is a rough patches, we can say. Right? There are heel and dents, we can say, which get interlocked in themselves. So we got the cause, we got the friction. Then we saw what are the different laws of motion or properties, you can say, friction or motion, friction. It depends on what? Nature of the surfaces, then it is independent of the area, then proportional to our normal. We have already used this formulas also, right? Then this point is important, that is, it is self-adjusting, means it's adjusts its own direction as well as magnitude. Then we saw the three types of motions, not motions again, friction, right? So three types of frictions there. Static force of friction, when the body is at rest equilibrium, then we can say it is a static force of friction. So if you apply some force, friction will also get that much of magnitude, right? But we know it also has the maximum limiting value up to which we can apply the force, right? So after, if you apply the more external force, if you overcome that external maximum value, which is called as limiting force of friction, what is going to happen? That body will start moving. Then we learned about the kinetic force of friction. Once the body starts moving, there is still some kinetic friction, but which will be less than our static force of friction. We draw the graph also. That graph is also important, right? Then finally we saw some of the rolling friction. What are the applications of the rolling friction? Obviously, our skating shoes, skateboard, etc. are our rolling friction applications of rolling friction, we can say. Or we have also seen this small example of this sheep which is pushed into the water using this rolling cylinders, we can say. Right? So these are the different things. Now let's try to solve some question. Static friction. This is static friction. Yeah, same they have given us. Okay. Now let's try some questions here. The object of mass 2 kg is sliding with a constant velocity 4 meter per second on a frictionless horizontal table. Right now, they are saying this is a frictionless. Remember, in any problems or MCQs, they are going to mention it is a smooth surface. Right? Smooth surface or frictionless surface means what? Whenever there's a frictionless or smooth surface, remember, frictional forces, we should take it as zero. Practically, it is not possible. Frictional force is never zero, right? But now here we can consider the frictional force is zero. So what will happen? What they are asking, this object is kept on the table, and now we want to move this object with constant velocity, let's say 4 meter per second. Now remember, this part is very important here. There is constant velocity. Now anybody tell me, when we say velocity is constant, what is the acceleration of that object? Zero, right? You can imagine you are riding the bike, let's say 40 kilometer per hour, right? If you're going on with the same speed, do you use that acceleration of the bike? No, right? Why? Because that's why the velocity remains constant. If you use the accelerator, in speed will increase, right? So as long as velocity is constant, what I can say, acceleration is equal to zero. And remember, our forces formula, I can say force net is what? Mass into acceleration. If the acceleration is zero, force net, I'm using the word net there. Net means what? There are different lot of forces acting on that any object, right? We know that. So net force should be zero, right? So even though the object is moving, it is moving with the constant velocity. Therefore, acceleration is zero. Therefore, net force is equal to zero, right? So the force required to keep the object moving with the same velocity is. Now tell me, in this case, as we said that it is a smooth surface, frictional force is zero. So who is opposing this force or object? Is anybody opposing this object? Neglect the air resistance. Air resistance is not that big a force, right? No, there is no opposition as the friction force is 0. So if there is no opposition, do we need any force to keep it moving? No, right? So therefore the applied force or required force will be 0 Newton, we can say. Okay, this is related to Newton's laws of motion. If you do remember, body in motion will keep going in body in motion, we can say, in state of motion, unless and until external force is acted upon it. So there is no external force acted on this case. So therefore we can say it is 0. Okay. Now let's say second question. Friction. Friction is a contact force, non-contact, magnetic, none of this. Simple question, right? We have already seen this in the previous chapter that friction is a contact force. Theoretical question, simple question. Then, what kind of substances are known as lubricants? Now, actually, lubricants we are going to study it in the next session, obviously in this chapter. But if you do know lubricants means consider oil, right? Oil is what? Oil is lubricant. It does the work of lubricant in our bikes, we can say, or you can even consider simple uh, examples of our door when it is making some cracking noises, right? You must have heard those noises in horror films, right? Horror films means whenever there is a haunted place or bungalow, we can say, obviously those doors are making some cracking noises. So those cracking noises, if you want to remove those noises, what we have to do, we have to apply some lubricants there. Means it could be a grease or oil, right? So those are called as lubricants. What they do actually, we just logically, are they increasing the friction or decreasing the friction? Obviously, right? They will decrease the friction, right? Because that friction was actually creating that cracking noise, you can say. Okay, simple. Then on what force the friction depends? Smoothness of surface, roughness of surface. We already seen in the laws, right? The friction or force of friction depends on nature of the surface. Nature of the surface means it could be a smooth surface or rough surface. Right? So it depends on both. What about the inclination of surface? Right? Now again, this part we are going to discuss in the next session. But remember, if block is resting on this inclined plane, which is making some, let's say, angle theta, obviously frictional force is going to change. So it depends on this force too, right? So I can say this is all of the above. Okay. Then maximum value of static friction is called as, very simple. We have learned this limiting force of friction, right? Simple. Okay. So these are some questions. So we have completed the first part of our friction chapter, which is very easy, right? Just three types we are supposed to consider. We also seen some examples. What is friction? Where the friction acts. Now, in the next chapter, we are going to study a little bit about the fluid friction and why the friction is necessary. Right? It is called as friction is necessary evil. Evil means obviously bad thing. We already know that friction is a bad thing, right? But why it is necessary? We are going to see that applications. We are going to see that. Okay. So in next chapter, we are going to study all these things. Just the theoretical concept. These are the important concepts we can say which are useful for solving the questions or the problems. We can say those are dependent on all kinetic friction, rolling friction, etc. And in next chapter, next session, we will see some theoretical concept about the friction. Okay. So we'll stop here today. If you do have any questions or queries, please post them on the forum so I can solve that. Right. So it will be taken care of and your doubts will be clear. Okay. So no problem. So today we'll stop here. Thank you very much. Have a nice day. Bye.